Hello, great mathematicians. Welcome back to our series on matrices. This is lesson 9 of our series on matrices. And today we're going to look at application of matrix multiplication. The concept of matrix multiplication is widely applied in the day-to-day arithmetic. So the day-to-day business you are always going through, you are applying matrices. Below are some illustrations of matrix multiplication. The first application of matrix multiplication that we are going to look at is solving for unknowns using matrix multiplication. So let's have an example there. Example. Determine the values of x and y. Okay, determine the values of x and y. So we are given this matrix. This is a matrix. We have a 4, 1, x, negative 1, x, y. So this is a column matrix, and this one is a 2 by 2 matrix. This one is also a column matrix. So they are telling us that if we are given this matrix multiplied by that matrix and you get that, so they want you to find the value of x and y. These are unknowns. Okay, so what we have to do in this case, we are going to form equations. So we deal with the daily matrix multiplication that we have been dealing with. So we know the matrix multiplication that we have been doing, that if we are given matrices of this nature, first of all we need to know the order. Is it compatible with the other? So that one is easier for us to understand. So if this matrix can be multiplied by that, then it is easy for us to form equations and find the unknowns. So I'm going to directly multiply this matrix with this matrix and I get that answer there. So if I'm to multiply the matrices, I'm going to have 4, of course, remember, row by column. This row multiplied by that column. So I'm going to have 4x plus y. Then there's no other column, so we'd go down. So this is x squared, okay, plus negative y. So this is a matrix which is equal to 4, 8. Okay, let's form equations. This with that, it goes, it's a linear one. So it is 4x plus y is equal to 4. Let's call that equation 1. X squared minus y is equal to 8. Let's call that one equation 2. Now let's deal with the equations. Let's say from equation 2, y is equal to x squared minus 8, and let's call this equation 3. Now we are going to substitute equation 3 in equation 1. So substitute equation 3 in 1. So if I'm substitute equation 3 in 1, I'm going to have 4x plus y, which is in this case x squared minus 8, which is now giving us a 4. So we are having another equation there. This is a quadratic equation which you can either solve by completing squares, or you can solve this by getting its sum, and I mean the sum of roots and the product of roots. So you can use that method for the roots, or you complete squares. So if I'm to get the sum and the product, you'll find that the sum, I'm going to have its sum as 4, and I'll have the product for this as 12, negative 12, such that if I'm to have the roots as negative 2 and 6. If I'm to add these, I'll get the sum as this. If I'm to multiply them, I'll get their product as that. So these are the roots, and this is the sum, and this one is the product of the roots. Now I'm going to have this as the x squared plus 4x minus 12, which is going to become, if I'm substituting the sum of the roots, I'll have x squared plus 6x minus 2x minus 12, which is equal to 0. Okay, then this one is going to become, I can factor out x from here. I'll have x into x plus 6 minus, I can factor out a 2 into negative 2, of course it is factored out, so I remain with x plus 6 is equal to 0. So you'll find that even this is common, so I'll have x minus 2 into x plus 6, which is 0. Okay, so now this one is going to become either, we are going to have either x as either x minus 2 is 0, meaning that x is 2, or x plus 6 is 0, x will be negative 6. For x is equal to 2, using equation 3, which is y is equal to x squared minus 8. So if x is 2, meaning that y is going to be 2 squared minus 8. Y is going to be 4 minus 8. Therefore, y is going to be negative 4. For x is equal to negative 6, y is x squared minus 8. Y is going to become negative 6 squared minus 8. Y is equal to 36 minus 8, and y is going to become 28. Therefore, we can conclude and say the values of x and y are x as 2, negative 6, and y is negative 4, 28. Okay. Example 2. Find the values of P and Q given that 3, 2, 4, 3 PQ is equal to 38, 25. So we are given that expression and we are required to find the unknowns, that is P and Q. Okay, now we are going to do the usual mathematics that you have been doing, multiply the matrix and get the unknowns. So it is row by column, so it is this with this, so it is 3 times 4 plus 2 times P. Okay, then we go here, it is 3 times 3 plus 2 times Q. This is equal to 38, 25. So we are going to have 12 plus 2P. We shall have 9 plus 2q is equal to 38, 25. This is going to be equal to that, and this is going to be equal to that, and we form equations. So it is 12 plus 2p is equal to 38, meaning that 2p is going to be 38 minus 12. I take this one this side, okay? So if I subtract 38 minus 12, I'll have 2p as 26, and my p is going to become 13. Okay, let's equate this one with that. So here, let me do this such that we can be able to look at it very well. This goes with that, okay? Then this goes with that, okay? So equate that with that, that with that in their corresponding positions, okay? Then here I'm going to have 9 plus 2p is equal to 25. 2p is equal to 25 minus 9. 2p is going to become 16, and p will become 8. As simple as that. So we can apply matrices in many forms. That is one form of applying matrices, whereby we use matrices to find unknowns. Hope that one is clear for all of us. Now, next video, we are going to apply matrices on the daily life that we are always dealing with. Okay, so next time, let's meet. Please don't forget, subscribe and turn on the notification button.